Hi everyone. In this video I am going to discuss about example of static error constant. This example is the previous examination question in the year JNTUA previous examination question in the year April 2021. Find the various static error constants for a unity feedback control system whose open loop transfer function is g of s is equal 10 into s plus 2 by s square into s plus 1. Coming to the solution, given that the open loop transfer function g of s is 10 into s plus 2 by s square into s plus 1, and also given that unity feedback system, so that is h of s is equal to 1. So calculate static error constant. Basically there are three types of static error constants, so that are position error constant, velocity error constant, and acceleration error constant. So these three are the static error constant. So first determine static position error constant. Position error constant. So we know that the basic expression of the position error constant k suffix p is equal limit s tends to 0 g of s into h of s, given that g of s is 10 into s plus 2 by s square into s plus 1 into h of s. For unity feedback system, h of s is equal to 1, and now applying the limit value s is equal to 0. Now applying the limit value, the position error constant k suffix p is equal 10 into 0 plus 2 divided by 0 square into 0 plus 1. So that is equal 10 divided by 20 divided by 0. So constant by 0, infinity. The position error constant value is infinity. And the second type of the static error constant is velocity error constant. Velocity error constant. So we know that the expression of velocity error constant k suffix v is equal limit s tends to 0 s into g of s into h of s. Substitute g of s and h of s values into this equation, we get the velocity error constant kv is equal limit s tends to 0 s into g of s is 10 into s plus 2 by s square into s plus 1 into h of s is 1. So that is equal limit s tends to 0. Here the numerator and denominator 1 s is cancelled, and the remaining term is 10 into s plus 2 divided by s into s plus 1. Now applying the limit value 10 into 0 plus 2 divided by 0 into 0 plus 1. So that is equal 20 divided by 0. 20 divided by 0 is infinity. Next, third type of the static error constant is acceleration error constant. The expression of acceleration error constant k suffix a is equal limit s tends to 0 s square into g of s into h of s. Substitute open loop transfer function and unity feedback control system values into this equation. We get the acceleration error constant Ka is equal limit s tends to 0 s square into g of s value is 10 into s plus 2 divided by s square into s plus 1 into h of s is equal to 1, and numerator and denominator s square is cancelled, which is equal to limit s tends to 0 10 into s plus 2 by s plus 1. Now applying the limit value, substitute s is equal to 0 10 into 0 plus 2 divided by 0 plus 1, so that is equal 20. The acceleration of error constant Ka is equal to 20.